Hey guys, jumping into the power generation mini series. Hope you don't mind. I brought my co-host along, Rocky, who is just hanging out. He has been chasing a fly around the house. It keeps messing with him. But anyways, let's jump into it. So in the power gen space, today we're going to be talking about Flue Gas Desulfurization, or FGD. And now there's a lot of different things within that process. From pumps to ductwork, precipitation tanks, and different things like that. Our focus is going to be on the ductwork with this video. And so for you guys, a couple key focuses is one, there is your inlet duct to the absorber. And then there's your outlet duct. So most commonly with your inlet duct, that's coming right off of the process. Now there are a few stages in between to help pull out a lot of the high solids, your fly ash, your things like that. But for you guys, that is a high temperature side to the absorber. So you could be 300, 400 degrees Fahrenheit and have a lot of material moving through there as well, in addition to your airflow. On the inlet side, what you guys are going to have here is this is all post absorber. And so with that, it's still higher temperature, probably in the 170, 180 degrees, in that range. But a lot of your solids now have been pulled out because it has gone through the absorber. You could still have some, but for the most part, that should be relatively low, especially because this is right before you're going out the stack. So you do have EPA requirements you need to meet. Now, the question is, what are we doing and what are we trying to achieve? So on both sides, we have a lot of corrosion just because of one, the temperature, two, there's a lot of different chemistries floating around in there, and three, you're pairing that with abrasion because you do have media going through it. So on your high temp side, your inlet side to the absorber, again, you're in that 300, 400 degree range. One of my go-tos is going to be an epoxy paste with some sort of ceramic in it to mitigate a lot of the abrasion. Now, can you go with a thin film system? Yes, and it's recommended, especially if your ductwork is thinner in nature, if it is flexible, if that system is gonna move more, you're gonna want something that has some flexibility to it. And again, we're talking inches, not miles here. It's not moving a lot, but it will cause a thicker system to crack. Now, if your system is very firm, it's rigid, you have no issues, as I always say with ceramics, if 1 inch is good, 2 inches better, 4 inches is even better than that. Not saying you're gonna put 4 inches of material down, but a higher build paste, it's just gonna increase your longevity, and just overall, your chemical resistance isn't gonna change because it either works or it doesn't, but it's gonna be a better system than thin film, all else being equal. On your outlet side, we can do either a thin film system or a thicker system. In a lot of cases, the thicker system just isn't needed because, again, you've removed most of those solids out and now it becomes a corrosion problem, most commonly a dew point, where you have your cold wall interface, so you start getting that condensation and you start causing failures. So for you guys, typically what I recommend is just a ceramic grade, fluid grade lining system there. It will help mitigate any abrasives if there is anything left in the system, and is also just perfectly geared towards the corrosion that's already in that environment. Again, your chemical resistance needs to be good, but it doesn't need to be the best. You could put a Novolac here, but typically what I'll use is a good workhorse Bissé resin with ceramic paired into that, and overall it's just going to give you a good system. So with something like that, you're going to be in that 20, 30, 40 mil range. Again, more is better in terms of abrasion, not necessarily chemical resistance, but that's up for whoever's specifying for you. I would at least fall in that range to give you long-term feasibility. Now, most cases when we do something like this, especially on the outlet side where it is those cooler temperatures and far less abrasives, I'll say, hey, you're going to get 10 years out of this because that's what I have to say. You're more likely going to get 15, 20 to 30, barring any unforeseen circumstances. On the inlet side where you are running high temperatures, you are running more abrasives, I like to keep it in that 5 to 10 year range. Can you go beyond that? Yes, with more material, but it's just more aggressive, and on startup when you have higher temperatures, you're just more prone to degradation that the thicker film systems will resist, but can't completely get rid of. So if you guys have any questions on these type of applications, drop a comment down in the description below. I'd be happy to talk with you, go through your options, see what's going to work for what your time frame is. I know some coal power plants out right now are saying, hey, we're going to be here for 2 to 3 more years. Others are saying outlook looks good, we could be 15 years, upwards of 20 to 25. So again, if you have any questions, comments, concerns, want to share an experience, drop it in the description below. I'll reach out and we'll connect. Take care, guys. Godspeed.